when I'm trying to send many rays of light like this, send a lot of rays or beam of light, it will start spreading out. So that becomes a convex lens. Convex mirror, sorry, mirror, don't make that mistake. Mirror, hold like this. You can see the hold like this.
Namaste, Hare Krishna. Today I am going to demonstrate to you the laws of reflection. For that we need very simple items. You need a mirror, a plain mirror. You need a screen which is made with white paper. I've just put a white paper on a cardboard box which stands as a screen. Okay, so you will have it placed in front of the mirror. Okay, you have a laser light. Okay, so I prefer the red color one so that it is very clear. And usually when these reflection lessons are experiments are done in dark room, the effect is very visible. Okay, effect is more visible. Now I'm also having a protractor just to say which I'll be talking in the second law, the first law of reflection now. So you can see how I place the mirror. I'm going to this is a laser light, okay, which is red in color. I've taken laser light, and now you just see I'm going to incident a laser light from the screen side. Okay, so it goes there. It gets reflected from the mirror, right? Can you see that? Yes. So at that interjunction between the screen and the mirror, you see it getting reflected. So it means to say that the first law says that the angle of the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. This first law. This experiment is describing or demonstrates the first law, which says that the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. Can you see it, children? Yes. Yeah. That's a normal. Normal is 90 degrees, right? So see the incident ray coming this side? Okay, what comes in is the incident ray. What gets reflected is the reflected ray. And the normal from there is a 90 degrees. Okay, which is straight. Which is not, yeah, that is the straight line. You can see the black line, the vertical line. Yes, that's a normal line. So this experiment demonstrates the first law of reflection. Now, yes, any angle you can incident it will be on the same plane. Next, for the second law says that the angle of incidence is equal to angle of reflection. So for that we take a protractor. The reason is at whatever angle I am incidenting the ray, say 30 degrees, the reflected ray will be seen at 30 degrees. If I am incidenting the ray at say 45 degrees, the reflected ray, the angle of reflection will be 45 degrees. So for that too I take a mirror. Okay, I place the protractor. Okay, can you see that? Yeah, I'm placing the protractor very close to the mirror, and see that you don't the protractor is attached to the screen. There is no movement. Okay, so what happens is now I'm incidenting it at particular angles, and you will see at the same different angles, it will get reflected. You should observe it very carefully. So a protractor, from what are the degrees there in the protractor mentioned? 0 to 180 degrees, right? So now I'm incidenting it at various angles. You'll have to watch at what angle the reflected angle will be. I'm incidenting a light now. Okay, that's a normal. Can you see that? I've just inserted a pen to show that's a normal. So the angle normal is 90 degrees, children. So what happens is the angle the angle at which I'm incidenting is the angle incident ray, and the angle which this incident ray makes with the normal is called the angle of incidence. Okay, that is called the angle of incidence. The yellow pencil, between the yellow pencil and the pen, that's called the angle of incidence, right? Similarly, if after incidenting, the reflected ray, it gets reflected from the mirror, which is at the base. So suppose I'm incidenting at 30 degrees, it gets reflected at 30 degrees. Okay? Yes. So the angle of incidence will be equal to angle of reflection. So this demonstrates the second law of reflection. Just observe it little carefully. Now, see, can you see that? Yeah. So I'm incidenting a red color laser light. Okay. So after reflection, see how it goes. Okay. It goes to the other side, but at the same angle. That's the angle of incidence. The angle between the incident ray and the normal is called the angle of incidence. The angle between the reflected ray and the normal is called the angle of reflection. Can you observe it, children? Yes. And the pencil represents the normal line or 90 degree. See, observe it carefully. You'll see that. Yes. Yes. Can you see that, children? Yes. This whole experiment is to demonstrate the laws of reflection. I hope you all got it, children. Thank you.